Just a reminder, today's conference is being recorded.
So welcome again to our information session on oilfield data management using enterprise information management, which is a solution developed by our partner SGT, Simcom Global Technologies, developed using the SAP Enterprise Information Management Platform, also using pre-built content from SAP Business Objects Data Services, and using furthermore subnet Viva master data management. But all these details will be explained now in a second by Venky, and I don't want to waste your time, and I directly hand over here to Venky. Now it's your turn. Please go ahead.
Thank you, Dirk. Good morning, good evening, everyone. This is Venky from SGT, Simcom Global Technologies. As Dirk mentioned, we are SAP's preferred partner in the EIM solution area, Enterprise Information Management, and we have built one-of-a-kind solutions around leveraging EIM, Enterprise Information Management, specifically for oil field data management, oil and gas upstream and downstream and midstream. So just wanted to share with you the solution and our approach, and probably towards the end of the call we can take up some questions as well. This is the agenda: introduction and the data management overview, high-level solutions we have built, and then we are going to focus on mainly three areas. Considering the lack of time, we have taken three areas. One is the well master data management, and we will also briefly see a demo of the solution we have built. And the second area is material master, specific to oil and gas, leveraging the PIDEX industry standard, and also we'll see what are the other standards available out there. And the third area is enterprise asset master, and finally Q&A. So moving on, the solution what we have built specifically for EIM, Enterprise Information Management, this is the coverage of the solution. Our solutions cover mainly 5 aspects of information or data, if you may. The first one is data integration. The solution covers how to integrate legacy SAP, non-SAP applications. And data quality, we have pre-built content to run through the data quality management. And then data migration, if the customer is working on an M&A engagement, or a net new customer consolidating the legacy systems into a single SAP platform. The content covers data migration aspects. Then master data management, you take any customer, the challenges are, how do I have a single source of records, single version of truth? And that the answer is master data management. The solution covers pre-built content, leveraging SAP NetWeaver MDM. And finally, business intelligence built on top of the MDM and the operational aspects of data. And SGT has an initiative called Enterprise Data Management that is completely aligned with SAP's EIM platform, Enterprise Information Management. So from the technical SAP product perspective, the focus areas or the solutions we have built leverages mainly SAP Business Objects, focusing on data services, the MDM, SAP NetWeaver MDM, SAP NetWeaver BPM, Business Process Management for workflow management, and then the NetWeaver PI, or the process integration, or formerly called XI, Exchange Infrastructure, for integration, primarily for real-time integration, and finally the WebDyn Pro, which is the technology for the UI development. Just to give you a background, SGT has a very strong SAP practice, and traditionally we have been core R3 implementation partners, and leveraging our years of experience on the data, handling data, migrating data or integrating data. The solution we built originally leveraging the ABAP area For example, the LSMW, the BDC, the batch input, direct input kind of solutions. Once SAP acquired MDM and business objects, we actually converted all those classical ABAP-based solutions into the EIM platform. And that's how we have right now pre-built content, data management content for more than 150 SAP objects. And not only for plain vanilla cutting across the industry, cutting across the functional areas, business processes, we have also built oil and gas industry solution-specific solutions covering the well, land lease, material, covering the hydro, non-hydro on the downstream as well. So let's get on with the very first solution, which is Well Master. Let's briefly look at the business drivers. We all know, oil and gas lacks the industry from the integrated data management perspective. Of course, if you look at the other areas, the banking industry or the point of sale, the integration from data perspective, it's far more superior, better than the oil and gas industry. Oil and gas industry likes to get to that level of degree of integration, and because of that, the main challenges are regulatory compliance. Because of the inconsistencies and non-integrated fashion of data, how comfortable the companies would be from compliance perspective, or challenges in optimizing the production and maintenance. These are the three main areas on the Well Master side. On the land lease, how accurate the revenue accounting and production accounting that are being calculated. How accurate the master data is, how accurate your division of interest is, and what about the analysis reporting that you're doing on top of the master data, what you have, which might have duplicates and which could have inconsistencies across different systems. So these are some of the business drivers for oil field data management. The solution we have built covers the entire life cycle of well, covering from exploration, G&G, drilling, completion, and production, and also branches on to the land lease ownership area. So the solution leverages PPDM, which is an industry standard. Of course, there are two prime industry standards. One is the PPDM, the other one is the Energistics. PPDM is primarily for master data kind of industry standard. The single schema that the entire enterprise can leverage. On the Energistic side, that is primarily for exchanging the data more like a real-time interchange. So we chose the PPDM standard since we are dealing with master data, consolidated, and coming up with a single version of truth. So we leverage PPDM version 3.8 for our as the base schema, and we leverage the entire EIM platform and built the one-of-a-kind oil and gas upstream. So when I say data management solution, that covers your data quality side, which is validation, filing, and DQM, data quality management, cleansing, and also the integration, migration, and syndication. Those are the data management aspects of Well Master we have developed. Here is the process overview or the demo flow, what we are going to look at. Or in a typical customer place, the customer would have heterogeneous systems. Of course, there is no single enterprise-wide solution covering all oil and gas upstream or downstream specific challenges. So on the G&G, customer may have a couple of applications like OpenWork, GeoFrame, or on the drilling, they may be running WellView or OpenWells. And of course, typically any customer would be buying Well Master database from IHS. On the production accounting side, customer would be running PRA or any other competitor products like P2E. So So the landscape is typically complex and heterogeneous in nature. When we take the well master definition exists in pretty much all these systems, some aspects or other. For example, G&G would be interested in some of the exploration attributes of the well, and that's where it originates. When it comes to drilling and completion, there are different sets of attributes. Drilling may not be interested in all the attributes that G&G catches, and production revenue accounting mainly on the division of interest and revenue accounting perspective. So since well master definition is spread across so many systems, customer would have absolutely no clue the well I have defined in this system is it same as the well I have defined in another system. Even though for US customers, API may act as a unique identifier. What about the international customers? And even within US customers, what if the well API number that they are defining is not consistent? So the solution, what we have built is extract the data from these different systems, run through the data quality cycle, which includes, number one, profiling the data, understanding the data. Then we have actually built business rules, about 250 business rules around master header. We run through those validation rules, report the exceptions, and cleanse it, that is manual as well as standardized automated fashion. And once you have the clean set of records, load it up into MDM. And it's all done leveraging the business object data services. And then in MDM, we have built the a schema covering the different aspects of well, leveraging PPDM as I explained. And then finally, we also have built a data governance model, web-based solution, which acts as the entry point for all future well master creation and changes. So that is the process flow. So let's look at the components of the solution we have built. The first part is well data definition. We have built a repository in MDM leveraging PPDM data model, and we have also built the data syndication from MDM back to SAP ERP and other legacy systems. The second component is central MDM governance. MDM governance is, well, you have done the data quality part. I have, let's say, 20 different applications covering SAP and non-SAP. We have gone through the data quality, validation, and cleansing work, which could be both automated and manual, loaded up into MDM. Now, from this point onwards, how do I ensure that the data stays consistent? How do we guarantee that whatever messed up situation the customer is in right now doesn't happen in the next 3 years? And the answer is you need to have a governance model around that, and the solution what we have built is central MDM governance. Then the next part is the solution covering the integration and quality, and finally the syndication. So let's straight away jump into the demo. Typically this demo takes about 1.5 to 2 hours, so I will try to reduce it, condense it, and try to show the different aspects within about 15 to 20 minutes. So what we are going to see is a demo of well master data management. And this is the first aspect I was talking about, which is the MDM repository defining a single version of truth of well master. And this is leveraging PPDM data model. We have taken the PPDM and using our industry experience for a number of years, we have created one-of-a-kind repository schema covering the various aspects of well life cycle. This has the plus entities or tables, if you may, mainly two repositories. One is on the well side, the other one is on the land lease side. On the well side, as you can see, the well header, the activities, the drilling related entities and attributes, well log related, perforation, plug back, tubular, and the different aspects of the entire life cycle of well. These are the left-hand side. These are the entities defined in MDM, and on the right-hand side, what you see, those are the attributes in each entity there. So let's take a closer look at the well header. Well header, in total, we have about 2,500 attributes, defined from a PPDM as well as, with our experience. So let's look at the well header. It has depth related, and then kilobush, elevation, unit of measures, the log related, the platform related, and location specific like country, county, state related, the depth related information, and the status, the classical things like well name, well unique identifier. And then we have extended, this is to prove that the model what we have is extensible in nature. Of course, this is the starting point. The customer may not be willing to take all 2,000 attributes. This is a starting point. They will say, well, I don't maintain these attributes, whereas these 10 additional attributes, that's what we would maintain. So all the ZSIM attributes are the extensions on top of the PPDM data model. Things like the borehole type and the acquisition date, the first production date, and things like that. And similarly, on the land lease side, we have covered the land area, the relationship between the land and area, and lease, and things like that. All right, so let's move on to that. That's the PPDM data model. Let's move on to the governance straight away. As I mentioned, once the MDM is set up and once we have the single version of truth, how do we ensure governance and keeping the consistency? So what we have built is a web-based governance model for WellMaster, which leverages the WebInpro, NetWeaver, and BPM, Business Process Management. Here, a requester can log in and then request a well to be created or changed. So he can enter the government ID, for example, the API number, all other attributes like name, province, the drilling information related. Depending on the type of system that he chooses in the previous screen, he will be able to request a well to be created from exploration perspective or drilling perspective, completion perspective, or production perspective. So once the well is requested, it automatically runs through all the validation rules. I'm going to show you the validation rules that are programmed in the data services. For example, here he's trying to request a well. At this time, it basically checks whether the well already exists in any other system. If so, it automatically does the matching, duplication identification, as well as running through the 250 business rules, validation rules I was talking about. Here it is actually comparing the state code, county code, since it is a US well. It checks whether the well API number matches the API, county, and country code. So again, these rules are called from the data services side in an enterprise service-oriented architecture manner. So once the well is requested by the requester, it triggers a BPM, Business Process Management, and it triggers an email so that the approver would get a notification that John Doe has requested a well to be created. If you want to review, approve it, click on the link, and the approver basically takes an action, reviews this. He or she can approve or reject with a comment, so that it goes back to the reviewer. If everything looks good, the approver would say, the approver is typically a data steward. So you would have a data steward group defined, and the governance around it. What are the things the steward would be looking for? Because pretty much everything will be automated by the system. On top of it, If there are things to be looked at, manual stuff, the steward would review it and then approve it. Once it is approved, the requester would also get the notification that your well is approved. Now it is available in MDM. What you're looking at here is MDM Data Manager, and in the Data Manager, the well that was approved in the governance UI has been created right here. And this is 1178 Apache Gulf of Mexico well number 01034. It's been created. So that is the first part of the demo, showing the MDM repository and the governance model around that. The second one is going to be data services. Data services covers basically data integration, running through the validation rules, profiling, standardization, and cleansing. So we have built a number of jobs or the data flow and workflows within data services. What you're looking at here is business object data services, and the left-hand side, those jobs are pre-built content from SGT. Here, the first step is basically loading the reference codes that we are going to validate, like reference codes like the country code, state code, the API provided value, and also the different aspects like the well type, the well status, valid values. And let's assume that the customer has actually got a bunch of wells from IHS and loaded into an RDBMS system, and that's the scenario we are looking at now. We have pre-built mapping from IHS to the MDM repository PPDM model, and here we are pulling the data from the IHS. It could be IHS or any other standard legacy or prepackaged solution, like Turbine or Wellcore. And we are pulling the data from the legacy system and run through the profiling. Profiling shows what are the different aspects of the data, and by looking at it, this is called column profiling. By looking at it, you will know what is the minimum, maximum, average, and if there are any issues. For example, here it shows top 50 analysis of profiling. What are the countries I have the wells in? This one is USA, and there is a USS, which is a typo, clear typo. So by looking at this, for example, if the minimum and maximum, the well completion date, if you have any date, cutting across 17th century, you would clearly know that, the data is messed up. So profiling basically helps you to understand on a 30,000 feet level, a broad picture of the quality of data. And then after the profiling, we drill into the validation. Validation is going into each and every data records from the backend systems, run through standard set of rules. To quickly show you about the rules, we have actually come up with a set of business rules specific to well master. Here is a sample list. We have business rules, as I said, about 250 different checking the consistency of the data, conformity, completeness, the 6 different dimensions of data quality. Here, we are checking if, mandatory fields are provided, or does it match, the codes what we have. For example, the API country code and county code should match the API provided standard codes. And cross-validation, for example, completion date should be less than or equal to abandonment date, and true vertical depth, should be less than the target depth, and things like that. So these are the standard business rules we have built, and in the demo, what you are looking at here is all those rules are embedded in data services. In data services, let's look at, this is where we have actually implemented all those business rules. For example, county code should match the standard list of county codes. The well API number, as you know, well API number could be a 12-digit or a 14-digit well API number, and the first 2 characters must match the API provided standard state code, and the next 3 characters should match the county code provided by API, and the last 2 digits optionally it could be the actual bore level number. And this is again, of course, applicable only for USA. For international, unfortunately, we don't have a standard code, global code, but of course, different organizations as well as governments are working towards that. As and when it's available, we will be able to incorporate those. Till then, we have also for non-US companies, we have our own internal unique number identification schema for as far as well goes. So these are the validation rules, typical validation rules. We would be running through these validation and actually segregate the data into 2 categories, 2 buckets. One is pass, containing all the clean records. The failed ones are separated so that those failed ones can be reviewed and standardized. Basically, that is the cleansing part. So run through validation, it identifies what are the issues, and those issues are highlighted in this management. It's easy to use tool, the data services management tool, where our solution actually reports all the issues, and the failed business rules are highlighted so that the user or the data steward can drill into each and every failed user, failed business rule, and find out, go to the record level and check where it actually failed. And the last part is standardization. How do we fix the issues? If there are issues, how do we fix the issues? So this is another content, pre-built content that we have developed. We take the failed ones, run through multiple iterations of validation and standardization rules. In the sense, we have also built fuzzy-based string comparison. For example, if there are if there are basically inconsistencies. For example, somebody pinged me, sent a mail that Nakadushas has been spelled incorrectly with a blank in between. That's right on. That's one of the probably typos from the user who actually entered did a data entry. So those are caught by these standardization rules. It basically checks the names and it tries to automate the process of correcting it. So, and API number, for example, API number could be, the first 5 digits could be automatically fixed, provided the state code and county codes are accurate. So that is fixed first, and then, the API numbers are fixed. So running through the standardization, for example, the Glasscock, Nakadushas, all these things are misspelled with a blank in between, and we have pre-built content to actually, a fuzzy-based comparison. And as you can see here, those are actually fixed automatically using the standardization rule and, highlighted capitalized, so that, the county codes are accurate, and thus your API codes are accurate. And only then since within US at least, all the reporting, the government reports, compliance reports are based on this unique well identifier, and so the compliance, from compliance perspective, you are accurate. You are reporting the values, production and revenue values for these wells accurately, because the API is going to be consistent. So that is the second part. The third one is basically loading the data into MDM. Once we have cleansed it, the cleansing is basically 2 parts. One is automated as well as manual. If there is a missing piece, you have to fix it only manually. So once all those things are done, once you have a clean set of data, it can be loaded into MDM. Again, we have pre-built mapping from for example, IHS, we are talking about IHS. So this, what you're seeing here is IHS mapped to the MDM repository, the PPDM model. So that gets loaded into MDM, and what you see here is all the clean records are loaded into MDM. And from this point onwards, customer can have peace of mind knowing that the data, what they have in MDM is all clean, cleansed, all the business rules what we have built have been run through, and from this point onwards I can have a clean set of data, and I would also know the key mapping, that is cross-reference of well in one system is equivalent to another one. And unfortunately, due to lack of time, I cannot show the other aspects like syndication, where you can say that my exploration team has completed the exploration, the well master has been entered, and it is ready for drilling. So you promote, instead of re-entering all the data in another system, you promote it from the exploration system and syndicate it automatically using the syndication abilities of MDM to the drilling, for example. Once the drilling is done, again you can automatically, based on the well status, you can syndicate it automatically to the production system. So, so that is the last aspect, that is syndication. So we are back to the presentation now, and continuing the well master. We have seen the demo. Then the next one is material master data management. Material master, let's look at some of the business challenges and business drivers. Material is similar to well. Material is another most commonly used master data cutting across applications in a heterogeneous environment. Material will be there in a production system, maintenance system, you name it, the material master is used. So typically material master will have very high degree of duplicates. It's not only duplicates, but customers should be able to actually find out how much inventory they have on not only specific materials but also equivalent materials. The customer may have tons of materials, one type of material, whereas if they think that the material is not there for an equivalent one, they will not be able to leverage the existing inventory across plants, or even within a plant, or across companies. Think about a merger and acquisition scenario. Customer may grow 2 acquisitions, and inventory could be sitting in one company, and they are not able to leverage inventory sitting in one company to another company because these systems are not integrated. And the solution what we are proposing is basically based on the industry standard. There are 4 different industry standards specific to oil and gas. One is PIDEX, and Shell provides a standard, and there is an ISO standard. And what we have built, our solution is based on PIDEX and UNSPSC. So UNSPSC is a 4-level hierarchy standard, and PIDEX goes well along with UNSPSC. That's why we have chosen these two to define the material standard. The material taxonomy is tricky. Customer typically faces a challenge of, well, how do I classify my materials? The material standard attributes like material master, the regular stuff, the plant specific or sales specific, those can be easily captured. But what about things like the nouns and modifiers? Basically the classification characteristics of materials. Those are the primary challenges, and that's why we advise PIDEX. Of course, PIDEX is not an answer for all kinds of business challenges, but majority of the customers, PIDEX actually provides an answer, because The coverage is pretty wide. PyDex provides 4,000 plus dictionary templates. Here is an example, the centralizer, a bowstring attribute. What are the attributes specific to a bowstring in a centralizer? So PyDex typically has a 15 to 20 different attributes for this noun modifier combination. And talking about the solution, what we have built, the MDM, we have built an MDM-based repository model for Material Master. Material Master standard attributes like plant-specific or MRP views and sales views, those are the standard ones. But we have extended that to include PyDex and UNSP-specific standards, and we have created 4,000 different entities, leveraging all the publicly available PyDex noun and modifiers. The second one is the data services, which covers the data quality management solution, running through the data validation routines and transformation and mapping as well. Then finally, the BPM, the governance model, similar to what we saw on the well master side. We have built a BPM governance UI for Material as well. So here are some of the screenshots of the solution we have built. As you can see on the MDM side, we have, along with the standard material general data and plant-specific data, we have also built 4,000 plus noun modifier templates, and these templates can be leveraged for defining the taxonomy. And I want to highlight one thing. The solution basically covers the commodity materials as well as spare parts. And the next one is the standardization routines. The main challenge is, customer might not have caught or maintained all these different attributes, basically the characteristics and classifications for different types of materials. Which means the description of the material is also pretty poor. That is a standard fact. Customers typically would have engaged some kind of initiative. They would have started some kind of initiative every 3 to 5 years to cleanse the data and bring some kind of uniformity in material descriptions, because the description is the primary key used for searching for materials. If they have to search for materials, find out the equivalent ones, then the description is the primary key used. But here, the solution what we have built is two parts. One is we provide services for enriching the material attributes as well as the description. That is one part. And the second part is we also provide BPO or manual data cleansing and enrichment services, which includes basically researching the materials through different catalogs, websites, content from the respective manufacturers, and then bringing up, enriching basically the classification of these materials. This slide explains the 7-step process we typically follow for standardization and enrichment of materials. First is talk to the customer, find out the requirements, the nature of the challenges that they are facing, and then come up with a corporate standard, typically something like PyDex for the taxonomy and UNSPSC for hierarchical definition. Then material classification, for material classification, attribute extraction, what is out there in the existing legacy systems or SAP systems, and transform those into the corporate schema, the standard schema what we have developed. And just to explain these PyDex taxonomy, we have gone ahead in order to capture, maintain it on the SAP side, we have created standard, in the classification system, the characteristics for PIDEX. That is also part of the solution. Perform the enrichment. Enrichment is the process of actually, expanding the data that is already captured, and enrichment typically that involves a lot of manual and some semi-automated process as well. Normalization, cleansing, then description generation based on the different aspects, whatever we have done, expand it and generate the description so that the description is consistent across divisions within the company as well as geographic regions. And of course, across the systems, they may have 50 different systems maintaining materials, and typically each geo will have their own way of entering the description. So with this process, you can bring a uniformity across the entire enterprise. Then finally, do a dedupe so that the material duplicates are removed, and that these are the duplicates and these are the equivalent materials what I can effectively use. We are into the final part, which is enterprise asset master data management. Assets are basically the equipments, functional locations typically maintained in plant maintenance of SAP. Customers usually use other non-SAP solutions as well, like Maximo or homegrown legacy systems. Now, how does it apply to oil and gas? Oil and gas, of course, from conventional way, equipments are installed in wells. That is one part. Of course, in a traditional way, assets would be the traditional assets would be maintained by customers. And another aspect is for pipeline. For pipeline customers, the assets are linear in nature. That is, in a traditional plant maintenance perspective, equipments installed in different functional locations are physically addressable. In which plant or within which maintenance plant, or a physical address. Whereas if it is a pipeline company running across thousands of miles of the continent, it is pretty difficult to pinpoint where these assets are installed. And if we have to perform maintenance, even to locate these assets across the system, it becomes a challenge. So linear assets have their own business challenges. And of course, as most of you would know, SAP has come up with a linear asset management solution, which I believe is a ramp up. And we have gone ahead and extended our EAM, Enterprise Asset Management, data management solution to include the linear attributes as well. And this is applicable for not only pipeline, but other similar industries as well, like the railroad or utility kind of industries. So similar to what we saw on the other areas, our solution includes a data model for EAM in MDM. We have gone ahead and created a MDM repository for EAM, and that includes linear attributes as well. Then data quality management, that is validation, profiling, standardization, and integration and syndication, integrating with SAP ERP plant maintenance. In the future, it will be the linear asset management as well, and Maximo, how to integrate that. And we have also created templates for integrating legacy maintenance applications. And finally, a governance UI model. Here is the MDM data model we have created, covering the four main attributes or aspects of assets: equipment, functional location, measurement point, and task list, which are the maintenance plans from master data perspective. Okay, so we have gone ahead and defined these attributes, and as you can see in the screen, all the LAM or linear attributes. Linear attributes, what is your start mark, end mark, and the relative positioning, the start point, end point, and distance from these markers. Those are the the linear attributes of where these equipments or functional locations are located. Then data services perspective, we have profiling, validation, covering the 4 entities we were talking about. And finally, as I said, the integration and syndication, like once the data cleansing is performed, how do we syndicate it back to SAP ERP, for example, plant maintenance, or pull it from SAP or Maximo and bring it into the MDM. Now, we have in all the integration, migration, solutions, we have 2 flavors. One is using data services, business object data services, and the second one is using process integration, NetWeaver PI. NetWeaver PI we leverage typically for real-time integration or near real-time, whereas if it is mass batch-oriented integration and migration, we leverage the business object data services. Then the last one is the portal-based governance UI, pretty similar to what we saw on the Wellmaster. Is you need to have a central governance for controlling the user interface to request and approve new assets. So that's the end of the session. We covered well material and enterprise assets specific to oil and gas. So we can open the floor for Q&A at this point of time, and then finally we can summarize it in 2 minutes.